Hello and welcome to Ty Teaches Math. In this video, we will be solving systems of linear equations algebraically using two very common methods. The first of which is called substitution and the second of which is called elimination, okay? And for this first problem, I'm actually going to go ahead and solve it both ways, okay? Now, fair warning, I heavily favor substitution, so I'm going to use substitution as much as I possibly can, but I'm going to kind of show examples of both and when I would choose substitution and when I would choose elimination, okay? So we have our system here. Now, in the previous video, we solved these graphing. Remember, the solution to a system is a point or points at which the lines intersect one another, the graphs intersect one another. If you didn't watch that video, I'll put a link in the description below, okay? But let's go ahead and solve this one. And the first way I'm going to use is substitution, okay? Now with substitution, the overall goal is to have a variable solved for and then substitute that in for that variable in the other equation, okay? So what I mean by that is if I'm looking at this system here, and I'm looking at this top equation, for example, notice I could quickly solve for y. I can get y isolated pretty quickly, and I wouldn't have any fractions, okay? I really like that. That's when I use substitution. If a variable is already solved for, or I can quickly solve for one and have no fractions in the equation, I'm always going to use substitution. So I'm going to go ahead and use substitution first. So if I'm going to be using substitution, I'm going to solve for this y, okay? So the first thing I'm going to do is I'm going to subtract 3x from each side. So I'm going to have negative y is equal to negative 3x plus 2. And now all I got to do is divide each side by negative 1, which is going to make this y is equal to 3x minus 2. So notice I have y solved for here. You could solve for x. You can solve for any variable you want. It's just that y was the easiest one in this problem, and it didn't introduce any fractions, okay? So I have a variable solved for. Big whoop, big deal. What do we do with it? Well, now that we have y solved for, I know for a fact y is equal to 3x minus 2 in the system. So what I can do is take this 3x minus 2 and actually plug it in or substitute in for y in the other equation, okay? And the reason I would do that is because now this equation will only be in terms of x, which means I can solve for x. It's not going to have two variables, okay? You can't solve an equation for a variable, like an actual number, a numerical value, if there's more than one variable in the equation. So I'm going to go ahead and substitute that in. So this is going to become, and I'll kind of do it right here, 6x plus 3y. Well, y, we just found out to be 3x minus 2, okay? So y is 3x minus 2, so I substituted that in for y in the other equation, and that's equal to 14. So notice I didn't really change the equation at all. That's still y. It's just another way of writing y, okay? And now notice all this is in terms of x. This is an Algebra 1 problem now, okay? So now I can go ahead and solve for x, and to do so, I would distribute that 3 to make this 6x plus 9x minus 6 is equal to 14, and now I can go ahead and solve. So this is going to become 15x. Those are like terms, I can combine them, and I'm going to move the 6 to the other side by adding. So 15x is equal to 20, and now I would divide each side by 15. So x is equal to 20 over 15. But that's going to reduce to the fraction 4 over 3, okay? Oh no, a fraction. What can I do? It's just a number, dude. Chill out. All right, so now I have x is equal to 4 over 3. What that means is I know for a fact that the x-coordinate of the point at which they intersect is 4 over 3. Now, what do I do with this? And I'll substitute this in for x in either of the equations. It doesn't matter which one you pick. You're going to get the exact same answer for y. However, there's an even easier way. I have x is equal to 4 over 3, so what I can do is actually plug it back into this equation because I already have that solved for y. So I can just plug in x, boom, it's just a bunch of numbers, and simplify it, okay? So that's exactly what I'm going to do. So I'm going to make this y is equal to 3x, and x I just found to be 4 over 3 minus 2, okay? And that gets me y is equal to, well, 3 times 4/3 is 4 minus 2. So y is equal to 2. And there is my y, okay? Now remember though that this is a solution, so this is a point. So the solution to the system is going to be the point x, which is 4 over 3, and y, which is 2. And there is my solution. If you were to graph both of these in your calculator and use that intersect tool like I showed in the last video, you would get that exact solution. Now your calculator is probably going to have like x as 1.3 repeating. Just know that that's 4 over 3, okay? And that's using substitution, all right? Now, I'm going to go ahead and solve this exact same problem using the other method, which is called elimination, okay? So let me go ahead and get that ready for us. Let me get all this mess out of here. Okay, so now let's try elimination. Now, substitution, remember, I recommend using substitution when you can easily solve for a variable, which you can here, but you can also always use elimination, okay? You could technically use either method any single time. It's just that sometimes one way is easier than the other. Now, elimination means that we want to add these equations together or subtract these equations to where one of the variables eliminates, hence the term elimination. Once again, mathematicians, super creative, okay? So if I were to add these equations together as they were now, nothing would end up canceling, which means I need to alter one or both of the equations. Basically what I'm looking for, let's say, for example, I had a system and it was like 2x plus y equals 13, and another equation was 3x minus y is equal to 12. Notice if I were to add these two together, the y's would automatically cancel because they're basically opposites. One is 1, the other is -1. That's exactly what I want. That's exactly what I want for this equation up here. But we have to figure out what we are going to multiply that equation by. Now, to figure that out, you should look at both of the variables and their coefficients and think about what are the common multiples of each, okay? So for example, for x, I have 3 and 6. So the least common multiple would be 6, right? I could multiply 3 by 2 to become 6, and boom, they're the same number. Over here, I have -1 and +3. That least common multiple would be +3, right? I can multiply this top equation by 3, and now they would basically have the same coefficient. But you want it to be opposites. So at this point, it's really entirely up to you which one you want to cancel. I'm going to go ahead and normally I would probably cancel out the y's. I can multiply this top equation through by 3 because this would then become -3y. And when I add them together, they just cancel out. But I'm going to go ahead and cancel out the x's just so we can see kind of the other side here. So if this is 3x and this is 6x, the least common multiple would be 6 because 3 goes into 6, okay? However, I want this to be an opposite. So instead of making this 6x, I want to make it -6x, which means I need to multiply 3 by -2. So what I'm going to do is I'm going to multiply everything in this equation by -2, which is perfectly legal. As long as you can multiply an equation by anything. You can add an equation by anything, as long as you do it to both sides, okay? That's why when we solve equations, we're like, oh, I'm going to undo +2 by subtracting 2. But you do it to both sides. So as long as you do it to both sides, you can really do anything you want to any equation, okay? So I'm going to go ahead and do that. I'm going to rewrite these down here. So that would become 3 times -2 is -6, so that would be -6x. -2 times -1 is +2, so that would be +2y is equal to 2 times -2 is -4. And I didn't have to multiply the bottom equation by anything because it's already 6x. It's already the opposite. Notice how one is -6, the other is +6. So that's ultimately what we want. Now, in some problems, you're going to have to alter both the equations, but that's not that big of a deal. But this is what we ultimately want. Notice the x's are going to cancel if I add the equations together, which once again, perfectly legal. So I'm going to go ahead and add these equations together, and -6x plus 6x cancel out. They eliminate, hence elimination. So those cancel out to get us 0. 2y plus 5y, or excuse me, 2y plus 3y is 5y. And negative 4 plus 14 is 10. And now notice we have a really basic equation to solve for y. So I would divide each side by 5. I would divide each side by 5 to get y is equal to 2, which remember was our answer for y when we use substitution. So notice both of these get us the exact same answer, and that should make sense. So we have y is equal to 2. What do we do with that? Well, now we take this and plug it in for y in either of the two equations, okay? So I'm going to go ahead and I'm going to actually just plug it into the second equation. You can plug it into the first equation as well. Just be really careful with negatives, okay? Make sure, I always like to put whatever my number is in parentheses and then distribute, just to be safe, okay? So I'm going to go ahead and plug this into the second equation. So that would be 6x plus 3y. And the reason I'm doing this is so I can now solve for x. We have the y, we need the x, okay? Is equal to 14. So notice I just plugged it right in. And now I'm going to simplify this and solve for x. So 6x plus 3 times 2 is 6 is equal to 14. I'm going to subtract 6 from each side, okay? Which is going to get me 6x is equal to 8, and then I will just divide each side by 6 to get 8 over 6, which is once again 4 over 3, which gets us once again our solution of x being 4 over 3 and y being 2, okay? So that's how we can solve using elimination and substitution, okay? So from here on out, you can use whatever method you want, but I'm going to kind of give you my idea of which one I would use and why. So let's take a look at a new problem. So we got a new problem here. We have a new system, okay? Now, if I'm looking at this one, I'm looking at both equations, and it doesn't look like solving for either variable would be too easy, okay? I mean, it wouldn't be hard, but it wouldn't be the easiest. I would have to add a variable to one side or subtract, and then I'd have to divide. And what's unfortunate is that I'm going to end up with fractions regardless of what variable I choose and what equation I choose. If I tried to solve for 2 here, I would have to eventually divide by 2, and 2 doesn't go into negative 3. It does go in 8, but it doesn't go into negative 3, which means I would have a fraction. Same thing if I try to solve for y here. Negative 3 doesn't go into 2 or 8, and the same thing with this equation. So that's what I mean by can I easily solve for a variable. And then if that was the case, I would use substitution, but it doesn't look that easy. So I'm going to choose elimination, okay? I'm going to choose elimination. So when choosing elimination, you want to look at the variables and determine which one will be the easiest to eliminate. Now notice for the x's, the coefficients are 2 and 4. I'm going to ignore the negatives just for now, but the coefficients are 2 and 4. Well, 2 goes into 4. The least common multiple between 2 and 4 is 4. And since one of these is already 4, I would only have to multiply one of the equations. However, if I was looking at y, and you can still do this for y, it's just going to be a little bit trickier, okay? If I'm looking at y, the coefficients are 3 and 5. Well, I'm ignoring the negatives, 3 and 5. And the least common multiple between 3 and 5 is 15, okay? Now, neither of these are 15, so I'd have to multiply both equations. If I wanted this to become 15, I'd have to multiply all this by 5. And if I wanted this 5 to become 15, I'd need to multiply all this by 3. So I'd have to multiply both equations. Now, once again, you can do that, but the 2 and 4 are definitely going to be the easier of the two options because I only need to multiply one of the equations. I can quickly make 2 4 by multiplying this equation through by 2. Okay, so that's exactly what I'm going to do. I'm going to multiply this whole equation by 2. And it would be really nice because they're going to be opposites as soon as I do that. This is going to become a positive 4x and this is a negative 4x, which is what I want. Because when I add those together, they're going to cancel each other out. They're going to eliminate one another. So that's exactly what I'm going to do. So this top equation I'm multiplying through by 2 is going to become 4x minus 6y is equal to 16, okay? And I don't need to multiply this bottom equation, so I'm just going to rewrite it just to say organized. Equal to negative 10, And now I'm going to add these together. Now, just be careful. I would always kind of just double check to make sure I did multiply everything correctly, because the last thing you want to do is just make a simple multiplication mistake or just forget to multiply something by 2 in this problem and get to the very end and it doesn't work at all, okay? It's really frustrating, so just be really, really detail-oriented when doing this. But I double checked, 2 becomes 4, negative 6 becomes negative, oh, yep, everything checks out. So now I'm gonna add these together. The 4 x's eliminate one another. Negative 6y plus 5y is gonna be a negative y is equal to, in 16 plus negative 10 is 6. So all I'm left with is negative y is equal to negative 6, and I can just divide each side by negative 1, and I get y is equal to negative 6. Boom! Y is already solved for, half the battle. Now I just got to solve for x, which means I take this and I substitute it in for y in either equation. It does not matter. I'm going to go ahead and plug it into the first equation. There's not really an easier one in this problem, but I'm just going to choose the top equation because in the previous problem I chose the bottom. Okay, so I'm going to substitute that in. So I'm going to have 2x, and this is so we can solve for x, minus 3y. Well, I found y to be negative 6. Found y to be negative 6 is equal to 8. And now I can go ahead and solve for x. So it's going to become 2x. A negative 3 times negative 6 is positive 18 is equal to 8. Notice, be really careful when we're multiplying those negatives, okay? Now from here, I'm going to subtract 18 from each side to get 2x is equal to negative 10, which then I divide by 2 to get x is equal to negative 5. So that means our solution is the point x negative 5, y negative 6. Boom, there is our solution. That's what we are looking for, okay? So that was a problem where it was easier to use elimination. Let's take a look at one more where substitution would be easiest. Okay, so we have a new problem here. We have 3x minus y is equal to negative 2, and the second equation is 5x plus 2y is equal to 15. Now, you can solve this either way, just like I said, but personally, I would choose substitution because I'm looking at this first equation, I'm going, man, I can get that y by itself so easily, okay? So I'm going to solve for y in this first equation here and use substitution. It would be pretty challenging. It wouldn't be too challenging, but if we solved for any other variable in any equation, if I try to solve for x here or x or y here, I'm going to end up with a bunch of fractions, and that would kind of suck. So y would be the easiest one to solve for in the first equation. So that's what I'm going to solve for. So the first thing I would do is I would move the 3x over. So I'd have negative y is equal to negative 3x minus 2. And then I would divide each side by negative 1 to make this y is equal to 3x plus 2. Okay, and there we go. We have y solved for, so now we can use substitution. I'm going to take this 3x plus 2, which is what we got for y. We know y is 3x plus 2, and I'm going to substitute that in for y in the other equation. You always have to use the other equation. A common mistake I see some of my students make is they solve for a variable in one equation, and then they plug that into itself. And what ends up happening is everything kind of cancels out, and they go, oh, what did I do wrong? Well, you plugged it into the wrong equation, okay? If you solve for a variable in one equation, you must plug it into the other equation, okay? So that's exactly what I'm going to do. So I'm going to plug it into the second equation here. That's 5x plus 2y. Well, I just found y to be 3x plus 2. Okay? And that was equal to 15. And now I can go ahead and solve. So I'm going to distribute this 2. So this is going to become 5x plus 6x plus 4 is equal to 15. So this is now going to become, I can combine like terms right here. That's going to become 11x, 5x plus 6x gets us 11x. I'm going to subtract 4 from each side to move the 4 over. So it's going to be 11x is equal to 11. And now I can divide each side by 11 to get x equals 1. Halfway done. We have x solved for. I know what x is. I can now substitute that into any of these two equations or this one to solve for y. And that's what I'm going to do. I'm going to take this and substitute it in right here for x and solve for y. Okay? So this is going to become y is equal to 3x. Well, I just found x to be 1 plus 2. Okay, so that's going to become y is equal to 3 plus 2, which ends up getting us y is equal to 5. And there we go. We have our solution. X is 1, y is 5. It's the points, and there is our answer, okay? And once again, you can double check by graphing both of these once you have them in slope-intercept form using that intersect tool, and you would notice that they would intersect at 1, 5. So that is solving linear systems of equations, okay? Systems of linear equations, that's how you're supposed to say it. I will make another video where I cover some special cases, because there are some special cases, just like where with graphing you could have no solution or infinitely many. The same thing can happen here. So I'll cut in the next video, it will be strictly a special cases video, okay? But after that, we're gonna get into systems of linear inequalities, graphing those, and those are pretty fun. So I hope this helped you. If you have any questions, feel free to let me know, and I look forward to seeing you in the next video.